Uh, Hello everyone, good evening and welcome to the webinar. First of all, I would like to thank you for joining today's webinar. So my name is Pekhar Omar and I am going to take few minutes of your time to explain you about the ground rules of the webinar and give you a quick introduction about our company, what we does and who we are. After that, we will start our webinar and hand it over to the trainer. So we have some basic ground rules for the webinar. So you all are in your mute mode and you will be unmuted at the end of the webinar for the question and answer round. During the session, if you have any query, you can type in the chat window and our technical leaders will answer your question. This webinar will be recorded and we will be sharing the recording with you on our YouTube channel. You can subscribe our YouTube channel and look for the recording. So let me move forwards and tell you about our company. So let me give you a introduction about us. So we are globally recognized and most trusted DevOps certification provider. We design DevOps certified accredited certificates that is accepted all over the world, and our DevOps learning engineer are certified and all. Apart from this, we also provide career counseling, mentoring, and training to fresh graduate, postgraduate from different companies and universities across the globe. You can visit our website and get more information for the same. So next slide is very important. This is our on-spot offer, which we are running today for only the webinar participant, in which we are covering the cost of all the sessions and everything for you. The actual price of the cost is $295, and for today's it will be $266. So if you want to avail this over, our technicians and leaders will be sharing the link in the chat window. You can visit and register for the same. Okay. So this is our training batch. So our batch will be starting, and this is the timing in which you can join and answer take the trainings programs. Moving forward, so this is some of our testimonials from the person who have taken our courses, and you can see everyone has shared their testimonials on this. After that, we will having a Q and answer round for which in which you can unmute yourself and answer and question your answer. So after that, before wasting any more time, I would like to thank it over to our trainer so that he can start a webinar. So Anuj, you can share your screen and move forward with the webinar.
Sure. Thank you so much, guys, for sharing up the details. Welcome everyone, guys, on this webinar. So my name is Anuj, and I will be presenting this webinar with you. So I am a like full-time DevOps engineer. I'm a like a lead DevOps engineer working with a Fortune 200 company. I've been there in the industry from past 12 years. I have worked relatively on like from past 7 to 8 years in DevOps world. Before that, I was working as build and release engineer. I have been working up in different technologies, core technologies like Docker, Kubernetes, microservices, cloud, Terraform. These are the core technologies which at present I'm doing a lot of work. I'm working on a lot of freelance opportunities. I'm giving the corporate trainings. So during this webinar, I will be showing you a small demonstration on a key tool, on a very important tool, a perfect integration and a blend of Docker, Kubernetes, and Jenkins, where not only one, but we will be bringing three different tools together as a single integrations. So we will be touching upon that. We will be completely seeing those things, and we will show you like how exactly these different like integrations are really going to help you on that particular aspect. So that's what we really are going to talk about, and we are going to drive here. And I'll also share my experiences with this Kubernetes, and we'll share that how these tools are really going to be implemented in the organizations here. So let's see like how we will be going on. So the main agenda for today is that we will be going for the container orchestration. What is a container orchestration here? What is the requirement of Kubernetes? What is Kubernetes all about? Blend of Docker and Kubernetes, how they get integrated with each other, what's the relationship between these two, and of course, at last, a small demo where we will be performing the like a CI/CD pipeline kind of a Docker image and the Kubernetes deployment. Okay. I hope everyone is able to. Prakhar, can you see like if I am able to? I'm sharing the screen still.
Yeah, your screen is still visible.
Yeah, yeah, great. All right. So first thing first, what is container orchestration? It's a very important terminology. And I'm not even talking about Docker. I'm not even talking about the Kubernetes. I'm talking about a generic tool here. So container orchestration is a process in which we manage a clustered environment because uh, before Kubernetes, yes, definitely we used to work on the Docker, like a Docker applications and the Docker containers. But yes, over the period of time, we have went on with a different process. We have got these container orchestration tools, and these container orchestration tools are really helping us to manage the resources. Now, as you can see here that in this architecture diagram over here, so you have a container orchestration tool, which is available as an kind of we can call it as a control plane. We can call it up as, kind of a master node. And then you have the different worker nodes. So Kubernetes provides us the clustered environment, something where we can see like how the implementations is really going to work, and we will be able to take care of that kind of a setup here. So definitely that's where we will be able to perform the integrations and the setups all together. So here you can see like we have a different worker nodes, like different machines. And what we are doing, we are deploying our applications on these different machines here. I mean, from a single node, I'm going up and deploying across different servers. And what I'm deploying the application containers. That's what I'm trying to do here. So definitely Kubernetes is providing us a kind of a clustered mechanism, like a clustered architecture, using which we will be able to see like how the implementations is really going to work, and we will be able to get the specific outputs and the results here. So scaling, deployment, container lifecycle, like a load balancing, high availability, load sharing. There are a lot of concepts which we will be able to manage and handle with the help of container orchestration tool there. So container orchestration tool is one of the most popular tool which is used to manage containers, to have the deployment of containers conducted there. So you have a master node, and you have like multiple worker nodes, like multiple machines where you can remotely log in and have the containers deployed. So this is a very high level of architecture. Of course, there are some mechanisms which we will be like following and we will be executing over there. But yes, at a very high level, these are the different executions and the setups which we will be able to perform and conduct over here. So that's the kind of like an implementation which we will be able to conduct, and we will be able to perform on this case. Now, Kubernetes, also known as K8s, was initially designed by Google developers, and it was like being prepared around 2013 2014. At that time, Google developers developed this. But why exactly in the first place they have done that setup? The reason why they have developed or designed the Kubernetes tool, because when Docker launched in 2012 and 2013, people actually faced a lot of concern and issues in deploying the containers and managing. The same thing Google also faced, but depend like rather than waiting for someone to come up with a solution, they designed the solution. So they worked and they brought this Kubernetes tool. Initially, it was only an internal tool, but then they saw the power of Kubernetes and they felt that definitely they can go and they can move on with this particular tool over here. And that really helps them to grow to a next level, because they were able to resolve all the major problems with that. And plus, on top of that, they were able to host it up in a different manner here. So definitely that's like a kind of a high level of advantage which we will be able to get it up here. That the way that how these executions are really going to process, and we will be able to get those kind of flexibility. So that's the kind of implementations and the setups which we will be able to perform, and we can handle those kind of changes here. Now, what is the need of Kubernetes? The same reason which I was trying to explain over here, that Kubernetes is a great tool available there, and there are a lot of reasons why we would go for the Kubernetes tool here. The very first option is scaling. Scaling of virtual machine is very difficult. It's a very manual process and it's very difficult process. But if you talk about the scaling of Kubernetes, of the containers in Kubernetes, it's going to be very, very easy, and it's going to be very, very fast here. So scaling is one of the biggest benefit when it comes to the Kubernetes here. Second, service discovery and service management. Even that is also something which is very important, because when we are talking about the service discovery and service management, I mean, whatever the number of microservices you wish, like you wanted to deploy, you wanted to host, you can definitely go and conduct that kind of an options over there, right? So definitely that's the overall mechanism and the integration which we will be able to perform, and we can take care of that possibility here. So service management is again going to be very, very important, and it's going to be processed all together. Load balancing across multiple containers. So load balancing is also something which is important. I mean, if you have 100 containers, 200 containers, so that kind of containers, when we are looking forward, when we are trying to implement, so definitely we will be able to manage and handle the load across these different containers there. So whatever the amount of containers are there, whether it's like 5 containers, 10, 20, 30, whatever the number of containers are there, you will be able to use, and you will be able to handle that kind of a container setup over here. Container lifecycle management, easy deployment, rollback, a lot of stuff. All these are the different high level of advantages which we will be getting up when we are going for the Kubernetes implementation. So that's the kind of implementation which goes on there. So we really wanted to understand that how the containers deployment and the rollback and all these best practices are really going to be implemented, and it's going to be processed here. And of course, I will be showing you practically also, I mean, all the different stages where we will be having the pipeline, and how these like a code bases will be built out, Docker images will be built out, upload to the Docker Hub, and then Kubernetes. So we'll see all that particular architecture available there, right? So these are some couple of reasons why we want Kubernetes to be available there, because using this we wanted to see like how the implementations is really going to work, and we will be able to get the best practices and the setup conducted here. So definitely that's the kind of implementation which we will be able to perform, and we will be able to take care of that kind of a setup here. Now, if you talk about the Kubernetes architecture, I mean, I have already talked about that architecture, that when you go for the Kubernetes architecture, so we are really trying to understand that how the implementations is really going to work, and the setup is going to be performed here. So Kubernetes is popular for having a multi-node cluster. That's what we have Kubernetes popular available here. So we have different servers, different machines, which we can go and we can utilize, so that we can have that kind of resources available. So when you talk about Kubernetes architecture, so there we are definitely going to understand that how the management of resources we are going to perform, and we are going to do it up here. So we have a different resources and different specifications, which is really going to be available, so that we can see like how that mechanisms is really going to be working off there. You can see here that we have a Kubernetes master, and we have a Kubernetes worker. In Kubernetes master is used to manage the resources. And if we talk about the worker node, so we have the different worker nodes available. where actually the containers will be deployed, will be hosted. So what we do is that Kubernetes, as in like the like from a Kubernetes master, it's going to manage the different node machines on the worker node. So that's the kind of implementation which we will be able to handle, and we will be able to maintain here, right? And this is the best part about Kubernetes, that the load is not going to come on the master node. The actual load will be on the worker node, wherever we are doing the containers deployment and the application deployments there. So if any one worker node goes offline, you don't have to worry about the application will be shifted to the other worker node which is available. So you will be able to have all these different benefits and the advantages conducted over here. So that's a very high level of benefits and advantages which you will be able to get, and you will be able to see that kind of a benefits altogether here. All right, so definitely that's the kind of an implementation which we will be able to perform, and we will be able to take care of that kind of a possibility. So that's a kind of an execution which is really going to be performed, and we can take care of that kind of an possibility here. So that's the kind of setup which is really going to be achieved, and we can perform those attributes here. All right, now. Right, so you have different options. I mean, you have the GUI interface, you have the command line interface. Different options are really available, using which we can see like how that implementations is really going to work, and we will be able to take care of that kind of a setup here. So definitely that's the attribute and the mechanism which is really going to be working, and we will be able to see like that kind of a possibility here. All right, perfect. So that's the overall goal which is available there. Now I will show you, I mean, I have a Kubernetes cluster available, and I'll show you like how we can have a quick deploy to that, so that we can see like how that implementations is really going to work, and we will be able to get that kind of an attribute here. So definitely that's what we are going to touch upon, and we will be considering those possibilities here. Right now, I have a server with me. So I have got a server. You can see here that I have got the control plane like a Kubernetes master. Just like in this diagram, it's mentioned there is a Kubernetes master which is available there. Now Kubernetes master is just going to manage the cluster, and the actual containers is going to be deployed. You can see like on the worker node, the containers are being deployed over here. And of course, you have the CLI options, you have the GUI options, you have different interfaces using which you can go and have the pods or the containers deployed there. In case of Kubernetes, we don't call it up as in containers. We use a terminology called pod, which is a basic unit of Kubernetes. And these pods may contain one or multiple containers. So as per the diagram, you can see that we have container one here in pod, we have container one, container two, and container three. So these are the advantages. Now, typically, if you we may debate also that why we are not using Docker for that, right? So the simple fact is that yes, of course, I can go ahead. I can have a virtual machine. I can have a Docker installed on top of that. But after that, what's the benefit there? I may not be able to like if let's say if that machine is gone, or the network is gone, that virtual machine gets down. So what will happen? I will not have any kind of an access to that machine, and my containers will also be stopped there. So to make sure that we have a high availability, we have like a containers always up and running, we want to go for a clustered architecture, and that's what Kubernetes is providing us. That yes, we are going to have a bunch of servers bundle up together, and we can go all together and deploy the pods. And the good thing is that definitely when you have multiple servers, like the clusters in which I usually typically work is that in that we have like 2 to 3 master nodes and 200 to 300 worker nodes, because it's a organization level cluster they wanted to utilize. The whole organization is going to use that cluster, so definitely that happens, and they use that kind of an attributes there. So that's the kind of advantage we get with the Kubernetes, and it's always beneficial to us because we will be able to know like how these managements of resources we will be eventually doing and handling them. So right now for our setup for the pipeline execution, I have actually got one node only, but I can have as many as node machines and servers added over there. So it's completely depending on your requirement that how many servers you really wanted to have and you wanted to integrate over here, so that according to that we will see that kind of an options. All right, so this is a kind of a specific attributes which is really going to be working, so that we will be able to see those kind of an possible solutions here. Right now, if I talk about the difference between Docker and Kubernetes, the same thing. Docker is only talking about a standalone installation, whereas Kubernetes comes with a kind of a clustered architecture. So scaling, high availability, fast deploys, faster rollbacks. All those options are coming up as an advantage in case of Kubernetes. And of course, when you use the Kubernetes, all advantages of Docker is naturally going to come, so you will be able to handle, and you can go ahead with that particular stuff here. So definitely that's the advantage which is really going to be utilized, and we can take care of those kind of and possibilities as such there. Right now, so that's the kind of mechanism which is really going to be followed and maintained there. So this is a kind of a comparison at a very high level. Docker is a great technology, but Kubernetes is more preferable in production environment. No one is interested in having all the application containers on a single server only. It cannot handle millions of users connecting to the applications. So if you have a giant application, definitely you need the tools like Kubernetes, which can go ahead and give you a mechanism and give you a setup which can be fruitful to you, and you will be able to get that kind of an advantages there. So that's the high level of benefit which you will be able to get over here, and that's the specifications of the benefits. Now if I talk about the CI/CD pipeline, it looks like this. So you as a developer is going to do the code commit, code push. The changes is going to be uploaded to GitHub, right? And from there, the Jenkins, we will be invoking the build. So you will be having kind of a code build process. You will be having a Docker file, like a Docker build process will be going on. Once your Docker image is built out, it will be uploaded to the Docker registry, and ultimately at last it will be going for the Kubernetes deployment. Like it will be going up and making sure that the Kubernetes is going to be deployed and the code is deployed and hosted over there. And all these things you are doing, how you are basically going and performing these things automatically here. So that's the kind of attributes which we will be following, and we will be able to handle all those kind of an setup there. So definitely that's the mechanism, that's the implementation which we will be able to perform, and we will be able to take care of that kind of an possibility here. So that's definitely the approach which we have to follow here. All right, so let's see now. I have a Docker file pipeline with me, which is and I'm going to use over here. So this is one of the my Java based source code, right? Which I'm trying to host on a Docker image, and then ultimately I wanted to host it up or deploy it up on a Kubernetes cluster. So that's what I really wanted to do, and I wanted to perform so that I will be able to have my code deployed on a particular Kubernetes cluster here. So that's what I really wanted to achieve, and I wanted to perform it up in this case, right? So the reason why I'm trying to go and I'm trying to do these things is to understand that how the execution is really going to work and it's going to function. So if I talk about my pipeline here, so we have like code checkout, we have like kind of a source code build out, like where we will be like building up the source code. We will be then going for the Docker image preparation, like building out some couple of Docker images. That's what we are trying to do, and we are trying to perform it up over here. So once the Docker images is built out, we are uploading it up to the Docker registry, and ultimately we are deploying it up on a Docker hub there. So all these things we are doing into a single pipeline. We are implementing continuous integration and continuous deployment here. So that's the kind of approach and setup which we are following, and we are implementing it up over here. So this is the kind of a high level of advantage which is really going to be followed and maintained here. So again, a CI/CD, a typical CI/CD pipeline in which we are going for from the like code checkout, code base build, Docker image build, and then ultimately the code deployment with the help of the Docker containers deployment on Kubernetes as in form of Kubernetes pod. So let's see how it exactly happens. Some of the steps, like for example, Jenkins and Kubernetes integrations, I have already done in prior. But when in our typical course of this DevOps, we cover these different steps during our session to show that how the integrations really happen. So we cover that aspect. So here from a webinar perspective, we have a limited time. So I'm just trying to work as in like with a lot of pre-configurations, but I can share that what exactly the pre-configurations I have done. So I have got a ready-made Kubernetes cluster. Jenkins application I already have. So I'm going to go for a Jenkins application. This is my Jenkins application. So I will be integrating, I will be creating a pipeline in front of you, and we will see like how that steps are really going to work, and we will be able to have a particular application deployed here. So I have my Kubernetes cluster. So let me see. So as of now, I don't have any kind of an application deployed here on my Kubernetes cluster. So using my pipeline, I will make sure that the code base get deployed, gets hosted, and we can see like how the applications is really going to work. And we'll find out once our code base is deployed, we can go and have a access to our application here. So that's what we are really trying to do, and we are trying to put it up here. So here, what we are going to do is that we are going to create a new pipeline. So I'm also sharing this code repository. This is for everyone, and this is something that potentially we will be like I have a lot of repositories like that, and like it's like something which I use it up on like in our typical courses when we will be going on. I share these pipelines with everyone, and we create these pipelines in our session. So that's what we really do, and we perform it up here. So what we are going to do, we will be looking forward for the integration. So we are going to like I have a code repository. So we will be creating a pipeline, like a Docker pipeline, pipeline creation, checks out the pipeline, because majority of my configuration is in my like code repository only. So I'm using a public repo, so I don't have requirement of any kind of credentials. It's a public repo, and we really wanted to see like how the connectivity is really going to work, and we will be able to have that kind of a setup conducted here. So definitely that's the kind of attribute which we have to follow, and we have to create those kind of changes here. So this is the kind of and implementations and setups which we will be following, and we will be able to have that kind of a possibility. Yeah, so sorry. Right now, so here I'm going to just save it up and build now. So one thing is there. So right from the code build, Docker image build, and then ultimately the pods deployment, all the activities will be done right away on this case. So that's what we will be performing and we will be conducting here. So you can see here, like I'll quickly show you the logs. Let me go through that logs here. So the first thing it's going to do is that it's going to check out the code base, which is very important, of course, because without the code base, it's not going to really work for us. So that's going to be the first thing which we have to put it up here. Then we are going for the Maven clean install, like a Maven build, where the like a compilation of the source code, the test compilations, the test cases executions, packaging the applications, and then you can see like the Docker images is getting built out right from the scratch with no cache, and then it's uploaded to the Docker Hub also. See, it's uploaded to the Docker Hub. I can go to the Docker Hub and I can see because that Docker image will exist and it's uploaded over here. So in a very secure way, we are just trying to establish the connectivity, and we are trying to see like how that executions is really going to work, and we will be able to take care of that kind of an possibility, or a kind of a task here. So again, it's a kind of an step-by-step process which is available there. So in Dockerized pipelines, you're not going to only build the source code, you are also going to build the Docker images. And these Docker images is what you're going to get them deployed as a Kubernetes pod or a container. So this is where it's being basically used and generated over here. So here again, you will see that, okay, right now there is no deployment available earlier, but yes, we will be able to see like a particular deployment created here. So let's find out that if we really got a deployment or not. So you can see like the deployment is really created over here, and I have got that kind of an application deployed, right? So of course, I have to see that what is the reason behind the error message, and we can do the troubleshooting to see like what's the reason behind the failure. Okay, so some beans are not getting started. Why? Because it was supposedly to have a connectivity with the database. But again, database is not there because in this short time, we can only show you some limited aspects. So it's a Spring Boot application, and it's actually getting started. But of course, due to the lack of the database, the application is not fully initialized, and it's not really up and running there. But yes, of course, you can see here that although the application is not fully up and running, but still it's keep on trying itself, right? So it got like 4 restarts done there. But yes, it's deployed on the machine on the system here, so I can fix that by having a database. We can bring it up there, and the code will be connected on that. So usually the organizations, the applications are deployed on the Kubernetes, but the databases usually gets hosted on our physical infrastructure so that we can have a better integration and a better connectivity here. So this is how, but at least our executions, like from a pipeline perspective, it's a success. because the deployment really happened. The core base of the container or pod is not working, due to which it's not coming like as an expected results. But typically the CI/CD pipeline looks like this only, so that we will be able to see that how the executions is really going to work, and we will be able to get that kind of an attribute here. Right. So that's the kind of an like a system integration and the setup which we are going to do, so that we will be able to see like how that setup is going to work, and we will be able to get that kind of an option over here. So it's a CI/CD pipelines of the Kubernetes. Of course, Kubernetes is something which is really going to be deployed like that, so that we can get the different kind of an attributes and the options as such here. All right. So again, coming up to the same diagram, so you are like going for the Docker images like source code build out, then you are going for the Docker container build out, and then you are deploying it up as a Kubernetes pods here. So this whole life cycle is something which we are managing it up with the help of the Kubernetes cluster here. So that's a kind of an overall management which is really going to work, and we will be able to see that kind of an possibilities or the solution here. All right, perfect. All right. So with this one, we are pretty much done with this demo. It's a short demo, but yes, of course, we will be in the actual, like a topics we cover the Docker, Kubernetes, all these topics in a proper detailed manner, so that we can understand that what's the significance of these different tools, and what's the idea behind that. So definitely that's the different things which we will be touching upon, and we will be going for these different topics here. So I think it's a time now that we can go ahead and ask for the question. So I'm just going to unmute everyone. So please go ahead, guys. It's a time for questions, the doubts, and Q&A session. You can unmute yourself now. I have given everyone access.
Do you have any plan to schedule webinar on customization
Customizations.
on Kubernetes, like with the configuration file for prod by means prod by dev and test
We
environment?
actually do keep on we do keep on doing a lot of webinars there. So I think you have to get in touch with the DevOps like a university to understand, because we do have every month 1 or 2 webinars we keep on doing there. But as such topics are not pre-planned, so we pick up the topics, and which is very important for the participants, which can give them the idea. But surely we can definitely see that if something like that we can plan, and we can share those details with you.
Yeah, because the secrets are like you shown the your secrets in a Git file, which is not secure at all, and that should be in an encrypted file.
Which secrets?
Um,
There
the
is no
file.
username password into the Jenkins pipeline which I have shared. It's being stored up as Jenkins credential securely in Jenkins.
But I saw some credentials over GitHub. That's why I asked. Okay, leave
No,
it.
that's a
I will.
that's a, actually that concept is something which we call it as in credentials. So it's a, you can see here, this one you're talking about.
Yeah.
It's a credential ID. So we store the credentials in like into our Jenkins in a secure manner. So it's not an actual username. My username is this one. and password I have not shared here. So it's encrypted and store it up in the Jenkins. I can quickly give you that understanding. So if you go to the manage Jenkins and manage credentials, it's available over here, my username password. So you cannot see, you cannot access it, you cannot do copy paste, nothing you can do. So in pipelines, we don't share the credentials. And these kind of concepts, we learn it up in our Jenkins module.
Okay. Okay.
And
This is not.
yeah, Prakhar. So this Jenkins server is running on the AWS on the same infrastructure where your Kubernetes is running.
Yes, but you can deploy it up to any Kubernetes cluster. What we typically do is that we have a Jenkins slave on that Kubernetes server, so that from Jenkins master, I can invoke my kubectl commands on a particular Kubernetes master and do the deploy. So it's not necessarily to have the both the servers on the same machine. For a quick setup, we have done that.
And in the Kubernetes part, is this like a manually set up Kubernetes or EKS, the AWS provided Kubernetes?
Again, it's a choice to choice. I mostly work on the on-premises and AKS, sorry, EKS, Elastic Kubernetes Service. But even if you want to launch a AKS like Azure Kubernetes cluster, even that also something I can go ahead. So ultimately, we need a Kubernetes, whether it's an on-premise or it's a fully managed Kubernetes, it doesn't really matter. The integration or pipeline is going to remain almost the same only.
Okay, thanks.
So why do we need Docker Hub when we already have a GitHub? So is there
GitHub
special?
is actually used to store the source code.
Yeah.
And in this one, in this specifically my pipeline, I have used a Docker Hub to store my Docker image.
So are we saying we cannot store Docker images in the GitHub?
In GitHub, we have a kind of a registry, like a Docker registry, which is available there. But I'm having a free account, so I don't have an access to that. So we can use Docker Hub, we can use JFrog Artifactory, we can use the ECR, like Elastic Container Registry. We can use the Azure service, Azure registries. We can use a lot of public tools where we can simply go and have our Docker images stored there.
Yeah.
So it's not necessarily that you have to use Docker Hub. Docker Hub is just a free service available to us, and we are just exposing it. And but it can be anything, anywhere.
Okay, so when you attach your Kubernetes cluster to your Docker Hub or GitHub, right? So obviously not the GitHub, the Docker Hub to pull the images. So are there any certificates used to connect to that service from your perspective?
Authentication is used, but I'm actually using a Docker Hub. So Docker Hub by default gets connected with Kubernetes, so you don't
Oh,
have to do anything specially. That's the reason why I have selected Docker Hub. But when you
okay.
go for Kubernetes
Yeah.
with other services like JFrog or ECR or Azure Registry or Google Registries, or there are different tools available there. So in that case, those are third party tools. So you have to provide the authentications, you have to create some secrets, and then through that authentication, it's going to work. So, but
Okay.
by default, Docker Hub is like readily integratable there.
Okay. So the last question, like,
Mhm.
how useful is Jenkins in Kubernetes world? So why
Very
we need,
much.
like, why do we need Jenkins? Like just to build the source code and get it into the images? Like,
Let's not even bring in consideration code-based build, but I tell
mhm.
you a simple fact. In a lot of cases, when you wanted to connect to the Kubernetes cluster, you will not be given a direct access to connect. I mean, it's not like you can go to from your local system and access it. They will most probably allow you only to access from certain tools like Jenkins or maybe from a bashin server, so that in a secure manner you can access Kubernetes. So we enable Jenkins because we wanted to go for an environment from where we, in a very secure manner, we can have the code deploy, we can connect to the Kubernetes cluster. Just to avoid any kind of like a security risk, we are doing this kind of practice. Plus, on top of that, there is a benefit we get that the whole CI/CD approach or the build, the test cases, deployment, all those things we will be able to perform in a single go itself.
Okay. So because why I'm asking, because
Mm-hmm.
Kubernetes do have their own service accounts, and right, you can put up the rules or be like rule bindings and everything in Kubernetes. So that's why I was
That is
asking
for
what's.
authentication purposes only. That when you connect to the Kubernetes, so whether you need to have an access to a namespace to all the resources or you want to have a cluster level access, that's just authentication purpose. But how you're going to
Yes.
build the Docker image, how you're going to
Yeah.
like run your
So
test cases, how you're going to upload your Docker image to Docker Hub. So for that, Kubernetes is required.
so is it Kubernetes or Jenkins?
Sorry, Jenkins is required. Sorry,
Yeah.
Jenkins is required for that.
Yeah.
Yeah,
Yeah.
because you have to connect all these different dots. Of course, you can bypass Jenkins. There are a lot of tools are there. GitOps is there. Then we have Bamboo is there. TeamCity is there. A lot of tools are there. I'm not saying necessarily that Jenkins is the only
No,
one.
no. I was just trying to ask, like, how
Hmm.
it is, like, making
Yes,
an
yes. So it's
advantage.
just connecting the dots. It's just we
Okay.
wanted to have all the things done in a flow. Manually
Okay.
also we can do these. Otherwise, automation is the reason why we are doing for the Jenkins.
Okay. Okay. I get it. I get it. Thank you.
Yes, but you have raised a very good point that the majority of the work is actually done by Kubernetes only, like the pod scheduling, the management of the pods, everything. So, but yes, before that, we need to get this Docker image ready, right? Which we are
Yeah. Yeah. So
uploading
that is
the,
about the source
yeah,
code, right? How you are
yeah,
building, and
exactly,
it's nothing
exactly,
about the Kubernetes, but about the source code, what you have,
exactly.
how you
Yes.
want to build, and okay.
And if you don't want to deploy these source codes as a containers, you want to deploy some MySQL or some ready-made image from Docker Hub, then in that case, you don't need Jenkins. You can just connect to the
Don't need
Kubernetes and
Jenkins.
deploy the. Yeah.
Get it. I get it. I get it. Okay. Yeah. Thank you. Yeah.
Hi, do you have any pre-recorded session for a Jenkins which will give more insight on how to integrate with the Kubernetes cluster and do the configurations, write the Jenkins files?
Definitely. So, I'll inform the team. We will share it up over the email to everyone on that.
Okay.
Hi Anuj.
Yeah. Hi.
Anuj, is in the AKS cluster,
Mhm.
we have the pods, right? So
Okay.
when it comes into the load side, is there any way to understand the load balancing over there with respect to the pod side?
See, the thing is that EKS and not even EKS, we actually
Mhm.
have got a new feature called HPA, like a auto scaling, which is available there, in which we
Mhm.
don't even need to understand that how many pods we really require. As per the load, the pods will be scaled up and scaled down automatically. So these kind of features are available. Plus, as far as the pod size is considered, so pod size is something which is always going to be tricky because that's a specification we have to provide that how many memory and cores we need to provide for our application. So unfortunately for that there is no automation available which will give you that this is the memory and cores which you require, so some efforts is required there.
Okay. And one more question is that we can we get the monitoring details when the load is getting applied on the application? It comes to in terms for the pod side as well as for the cluster side.
Definitely. I mean, we have a separate like a CK there,
Mm.
certified Kubernetes administrator course, in which we talk about a component called metric server. Under that metric server, what we do is that we can even see these kind of attributes that how much load is coming on our pods, and the HPA, the auto scaling can actually do a real time calculation. Let's say if the pod the CPU utilization is more than 50%, it will scale up the pods. So that kind of metrics we can collect. We have a lot of monitoring tools like Prometheus, Grafana. They are the real-time monitoring tools available. Where using some dashboard, we can get the pod level load also, we can also get the worker node level load also in a very high level of monitoring.
Okay. Thanks, Anuj.
Yep. Anyone else
Hi,
also
hi.
have? Yeah.
So, like for the Docker thing, we need this Docker Compose, right? Like, how do we construct that
No.
Docker Compose file?
No, you don't need that. Actually, we only need the Docker file. So I can show you a quick Docker file here. So in this repo only, I have a Docker file in which I'm saying that, okay, I'm picking up a base image like an OpenJDK. Then you're transferring the artifact jar file inside the Docker image, and you're just invoking, like exposing the port and the invoking the java-jar and then jar file name. So you don't need any kind of a Docker Compose. Docker Compose is obsolete. People used to use Docker Compose when Kubernetes was not there, and they wanted to host the containers. That time they used to use the Docker Compose, but it's gone now. No one use it. At least from past 4 years, I have never used Docker Compose.
Oh, okay. So this Kubernetes helps for the hosting of the Docker images.
Yes, the containers deployment, it's the only solution, workable solution, which is available in the market. So there is another product called OpenShift, which is also internally using Kubernetes only. But this is the only solution which is available in the market at this moment of time, which is being used in the production environment. So you pick up any organization in the market, in the industry, they will be using Kubernetes for the containers deployment.
Oh, okay.
All right, great. Anyone else having any kind of doubts or questions, guys?
So in the GitHub, the first step is like the Docker Compose thing, right? I didn't get that.
Can you repeat once again? Once again, what are you saying?
No. In the GitHub, which was shared, uh,
Mm-hmm.
like the first step which is given for running up the services, they are using the Docker Compose thing, right?
In the Jenkins pipeline?
Yeah.
No. That, see, the thing is that Docker Compose is an old file. So you can see, like, it's been 5 years I have not touched upon this. So I used to train on these technologies, like here and there people used to ask upon that. But now I'm completely working, like you can see that I'm doing the changes to a lot of things, but not onto the Docker Compose file because I'm not using it. So in my Jenkins file, I'm only using the Docker file.
Okay. Got it.
So
Yep.
it's still part of the repos, but it's just an kind of like a dummy file. I can
Outdated
delete
one.
it also, no problem. Without that, also it's going to work. So I don't need to use this option necessarily.
Okay.
Great. Anyone else also having any doubts, guys? Any doubts or questions?
I think
Do
Anuj,
you,
yeah, go ahead. If you have any doubt, please go ahead.
no. Like the most of the code is in Java. Like, is there any way you can do it in Python?
Yeah, definitely. I have a different options. You asked me about Node.js. I even have that also. So, you have different functionalities. I may not have the pipeline ready for that, but The Docker file is available there. So it's not only about Java. It's like I have examples about .NET. I have the examples on Node.js, Spring Boot, Python, different options we really have, and we use those options accordingly. So when I will be sharing up these different repos with you, so you can see like how easily we can go and interact with these different resources all together.
Yeah, like for writing these custom Docker files, like any references for the syntax?
Syntax, I mean, the official documentation from the Docker itself is great for Docker file because apart from 13 to 15 parameters or attributes, there are not much attributes which is really available there. So we have a very, like a kind of a few options available altogether.
Oh, okay, like fine.
Hi. Sorry, I got disconnected in between. So the question I wanted to ask is about the CI/CD. So, what is meant by a CI/CD pipeline, and like what it really means in the Kubernetes world?
It's not actually related to the Kubernetes world entirely. CI/CD is a very typical terminologies like continuous integration and continuous deployment. So continuous integration is a process where we are looking forward for build automations, test cases automation, and in case of continuous deployment, we are looking forward for the code deployment, right? So we are pretty much like implementing these attributes, like we are trying to see like how that executions is really going to work, but it's just a high level of implementations which is really going to work it off there. So without Docker also, like if we this whole concept is there from past 7 to 8 years. I'm using this. Kubernetes just came in 2015 to 2016 only.
Correct.
So it's a generic concept. Without Kubernetes, if you don't have Kubernetes or Docker, still we use this concept here. We are just using or we are taking this leverage of this concept, which is being used to perform the build, test cases, and deployment of the containers. And Kubernetes is just a tool we are doing it. Instead of Kubernetes, we may have Ansible also. So we can use Ansible also instead of that.
Okay. Okay. So CI/CD is just a terminology, right? So
It's
nothing.
just one of the DevOps terminology and standard which is available, which is used to perform the build automations and the test cases automation of the code deployments.
Okay. Thank you.
Anyone else also having any doubts or questions? Anyone else having any kind of a doubts or questions, guys? Great. So I think, yeah, Rohit, we can see that you have raised your hand. So do you have any question for us?
Anuj, I have already asked. Right.
Oh, great. Fantastic. Wonderful. So I think that's it for today, guys. And thank you everyone for joining.